Now it's time to start taking an in-depth look at classes and objects. Now, a class, as we've already discussed, is the model or blueprint about the capability of what an object can do. An object is the instance of a class or the working entity of a class. The method is the same thing as a function, and it can modify a class's state or behavior. And if we look at the diagram below, we see the blueprint for a car design, which is the class, and the class will also have the description. A car that has been made from that blueprint is known as an instance of that class. So we can see we have our class, which is car, and then we have instances or objects of different types of cars. Now, say for instance we were to define an actual car class. It may have attributes such as fuel that will keep track of how much fuel our vehicle has. It may have an attribute of max speed, which lets us know how fast the car will go. And it will also have methods which will work on the different state and behavior of our class, such as refuel when our fuel gets low, set speed, get speed, and also drive. So these are just a few of the different methods and attributes that a car class may have. Now, we can't talk about OOP unless we get into depth about the 4 pillars of OOP. The first pillar we're going to look at is encapsulation. So this is accomplished when each object maintains a private state inside a class. Abstraction shows only the relevant details of the object. Inheritance is the ability of one object to acquire some or all of the properties of another object. And polymorphism gives us a way to use a class exactly like its parent, so there is no confusion with mixing the types. So in short, inheritance is the sharing of information, encapsulation is the grouping of information, abstraction hides the information, and polymorphism redefines the information. Now each class has access to a feature or utility known as a constructor. Now some classes need constructors to initialize member variables. Also, constructors have the same name as a class. They are essentially functions, but without a return type. Also, like functions, they can take parameters or not, and they can also be overloaded. Now let's look at some keywords to note when we are dealing with classes. First, we have the class keyword, and this is followed by the opening curly brace, and inside the curly braces you will have your attributes and methods and any other supporting code for that class, and it ends with a closing curly brace and semicolon. The private keyword with the colon lets us encapsulate our data. So anything that follows the private keyword will be hidden from the rest of our program. And when we do our demo, we will see why this is so important. We also have the public keyword, which is of course the opposite of private. So anything that comes after the public and colon will be visible and accessible by other parts of our program. We have our scope resolution operator, which we have used in previous videos, and this is the double colon. This allows us to actually tie our member functions back to our class and resolve it in that namespace. So an example of this would be our cout operator, which resolves to our std namespace. And we will be looking at how to create our own custom functions that have to be resolved to the namespace of our classes. Going forward, we're going to start looking at best practices when structuring our code. So first, it is best practice to separate our code into different files. So far in our course, we've just been writing procedural code, and we've been doing this in a linear fashion. But the best way is to actually separate your code into different files so that it is easier to scale. And by scale, I mean if your program has to be modified or if you have to add anything to your program in the future, it will be simpler and easier to do so if your code is organized properly. So this means that you should have one header file per class, and this header file will define the attributes and the method prototypes that deal with the behavior of that class. You should have one .cpp file per class that implements the functions. Also, the header file is always included in the .cpp file and any other file that uses the class, such as your main file. Lastly, I usually like to use the std : instead of using namespace std, as we've been doing so far in our program. And the reason for this is to avoid any clashes in the namespace and with any other header files that may be using namespace std. So usually I just like to use std : when defining my classes in the header files. Now, moving forward, it is highly important that you understand what a UML diagram is. So a UML diagram is based on the Unified Modeling Language, and its purpose is to visually represent a system. So UMLs can be used for modeling a system independently of a platform language. So it helps us to visualize, construct, and document information about software-intensive systems. So in a nutshell, a UML gives a standard way to write a system model, and it covers the conceptual ideas about this model. So here in our diagram, you can see we have a simple UML diagram, and it depicts a vehicle class which has the attributes of manufacturer and language. It also has two methods, getManufacturer and getLanguage. You can see on the top right hand corner that you can extend a class, and this is known as inheritance. And down below you can also see that we have two classes, Jeep and Ford, which are also inheriting from our vehicle class. So a class can be inherited from, and it can also inherit or extend another class. So before we dive into how to properly structure our classes, let us first look at a quick example of how to define a class right here in our main file, and also show how encapsulation works in classes. So let me do that right here. So we can define a class using our class keyword, and I'm just going to name my class example. And of course we have our opening and curly braces followed by a semicolon. So one thing I'd like to note, a class is private by default. So without defining a private or public, our class is private by default. Okay. Okay, let me undo this, right? Okay, so it's private by default. So without having to say private : or public : everything in our class at this point would be private. But I usually like to define the keywords just so I can know for sure what is private and what is public. So I'm going to define a private variable and call it message. So it's just going to be a simple string. And I'm going to define what are known as getters and setters. So you may have heard the term getters and setters before. And really what they allow us to do is modify our private variables. So this is the concept of encapsulation. So right now, our string message is hidden. So if, for instance, I created an instance of my example class. So to create an instance of a class, so let me say here, we're going to create instance or object. So in order to do this, we would need the name of the class. So in this case, the name of the class is the type, and then we give it our instance a name. Okay, so I can just simply call it EX and terminate it. So I've created an object called EX, and the type of this variable or instance or object is example. So let's say, for instance, that I wanted to set a value for our message right now. There would be no way to do this. So if I was to type in EX, and remember our dot operator is what allows us to access the members of our class. If I was to hit dot, nothing would show up. And the reason for this is because our message variable or attribute is private. If I was to move this and put it after our public colon declaration and come back here to my object and I hit dot, now we can see our variable message, and we can actually set a value for it. And if we wanted to print that value, we could say cout message. And if we run this, of course we get our value. Okay, so whatever this value is, we're able to print it out. So we're able to now access our variable. So the reason this is not good is because you do not want to be able to access your variables directly like this in your class. It's best practice that your variables are private. So for instance, if you have a class that holds the information for somebody's bank account information, you definitely wouldn't want the account balance just being anybody to be able to do this, to just go in and modify an account balance. You definitely want to set up a function or a setter which would modify that value, and also a getter which would retrieve that value for you. So this is a no-no. All right, so let me remove this, and I'm going to put my message back here, where it is private. Now, in order to set a value for my message, I am going to define a setter, and I'm simply going to call it set message. And this function is not going to return a value, so it is going to be a void. And we have our opening and closing parentheses, and then opening and closing curly braces. So I am going to pass in a variable that allows me to modify my message. So let me call it string m. And then inside my function body, I am simply going to say message. So we see here that the variable message is actually visible as long as I am inside my example class here. So as long as I'm within the curly braces, I can access my variable. So I'm simply going to say message is going to be equal to m. So whatever value the user passes in to this set message function, it will set the message variable here. And I have to not forget my semicolon. Okay, so now in order to set a message, we can simply type in the name of our object, dot, and we see here that we can now pass in a value of type string to set a message. So I'm going to say this is a message, the example class. So we have now set a value for our message variable. Now, in order to print this value, I'll need what is known as a getter. So let me come here and we're going to define a getter. And the name of your function can be anything. It doesn't necessarily have to be get message, right? It can be something as simple as print message. So your setter and getter can have whatever name you want to define the function with. So in this case, I'm not going to pass anything into my function parameters, but inside my function body, I am going to say cout, and I'm going to simply print my message. So back in my int main, in order to print my message, I simply have to just call my object dot print message function. And now if I run my program, you'll see this is a message from the example class. Okay, and let me just add an end line here. Right, so let's run it again. I don't know, I'm picky like that. So now you can see the result. So in a nutshell, this shows us what encapsulation is. It's really the hiding and showing of information. And we have been able to just simply set up a class here just to demonstrate that. So now let me remove this and get rid of this. So I'm going to set up our class using the proper methods with our header file and our supporting .cpp file, and we're going to set up a car class and the attributes and methods for it. So in order to do this in Visual Studio, you simply come here to your Solution Explorer, and here you see whatever you have named your project. In my case, I've called it Intro to OOP, and you see here all the different folders associated with it. Right now we have one source file, which is usually the name of your project, and it has int main inside of it. Your header files will be created inside this directory called header files, and all your supporting .cpp files will be created in your source file directory. So in order to create a custom class, you right click on your project, scroll down to add, and we're going to add a class. Now that's one way to do it. The other way is to right click, go to add, new item, and select class from here. So it allows you to add a CPP file, .cpp file, and a .h file if you just want one or the other. Okay, so that's another way to do it. So if I just add a class, it asks me what my class name is, and in this case, let me define my class name to be vehicle. So you see here it's going to add a .header h file, which is our header file, and a .cpp file, which we will use to put our member functions and our logic for our functions and methods. So if we click OK, it would have created our header file. See, we have vehicle.h in our header directory, and also a vehicle.cpp file. And inside our vehicle.cpp file, we are including the header file for our class. And of course, when we are going to use our class inside our main program here, we will also have to include it. So inside our vehicle.h file, we have this directive called pragma_once, and that simply just specifies to the compiler that it should only include this header file once. All right, so that's pretty much all it's there to safeguard against, that it's added only once. So we have our class already set up for our vehicle. So just like before, we're going to define private and public sections to our class. So let's include some variables here. So let's declare, let's first declare an integer, and I want to declare the number of wheels that my vehicle will have. So we're going to get into inheritance later, and we know that some vehicles have more than 4 wheels. So if we're dealing with a trailer, of course, you have some of them have 18 wheels, and some vehicles have more wheels than others. If it's a tractor, it may have 6 or 8 wheels. So we're going to define number of wheels. We're going to define the weight of the vehicle as a double. And we're going to define the type of vehicle as a string. So let's say string type. And you can see I'm getting an error in Visual Studio. So it's saying the identifier string is undefined. So what this means is that we'll have to include string. So you can either click on this little down arrow here, and it will prompt you to make this addition to your code. So if I click on this, it will include string for me, and we still have an error. Okay, I've already included string. So what it is now missing actually is the std::, because we have to define the namespace std to be able to use our string variable. All right, so that error message was not, suggestion was incorrect, as we've already included string. So remember, in my previous slides, I said that in my header files, I prefer to define std::, just to avoid any clashes in the namespace. So I'm also going to define one other method called hybrid, which will be a boolean. Okay, so this will just let us know whether our vehicle is a hybrid, yes or no, true or false. All right, so that's it for my attributes. Now for the behavior. So I'm now going to define a default constructor. So you have default constructors and you have parameterized constructors, and all a parameterized constructor is a constructor with parameters in it. So a default constructor does not have parameters. So right now we're going to overload our constructor. So first let me define a constructor for my class. So remember, the constructor has the same name as the class and it has no return type. So in this case, the name of my class is vehicle. So my constructor will also have the name vehicle. And I'll open and close my parentheses, and inside my square curly braces, I am going to simply set number of wheels to 4. So we are going to assume that the majority of vehicles that we are going to store information about will have 4 wheels. So I can say number of wheels equals 4, and that will set that value for me. Okay, so at this stage, whenever we create an instance of vehicle, the number of wheels will automatically be equal to 4. And to prove this, let us set up a function with a return of void, and let's call it print. Let's call it print vehicle info. And inside of it, I am going to say, I'm just going to print out the number of wheels. Let's put an end line there. Alright, so of course we need our std : to resolve the namespace. And there's another error. Okay, so this, okay, right, so we have to include IOStream also to be able to use cout, and our end line also belongs to the standard library namespace. Okay, so now let us create an instance of our vehicle just to ensure that when our vehicle is created, our constructor will automatically set the number of wheels to 4. So let's come back to our main file. So to create an instance, we have to say vehicle, and let's call it vehicle 1. Okay, so we're getting an error because it doesn't recognize vehicle. So of course our IntelliSense is telling us we need to add or include vehicle.h, which is our header file. So if we do vehicle 1, which is our object name, and we hit dot, and we call our print vehicle info function and run our program, you will see that our object already has set that value of our number of tires or wheels to 4. Okay, so that's essentially what a constructor does. So remember, a constructor simply, if you want it to, it can set the default value for you. Okay, so if we wanted to define another constructor, so let us overload our constructor, and in this instance I want to set up a parameterized constructor. So let me move this comment here to the side. So let us define another constructor, and now this constructor is going to take parameters. So let's say I wanted to be able to set the number of wheels and the vehicle type. All right, so let us pass in a value. So int, let's just say wheels, and let's say we're going to do string, and let's do t for type. And inside of our curly braces, and this actually should be a comma. So inside our curly brace now we can say number of wheels, which is the attribute in our class, will be equal to wheels, which would be the value that is passed into our constructor. And also type would be equal to t, which is the variable to pass in our string of our type string. Okay, so this is known as a parameterized constructor. So you see, we have easily overloaded our constructor. So in order to ensure that this works, let us add some more vehicle information. So that I don't have to type this information all the time, I'm just going to do a quick copy and paste. So we want to print number of wheels, and we want to print, second we want to print the in this situation I wanted to actually pass in the weight, so not wheels. So we're already setting number of wheels in our default constructor. So in our second constructor I'm just going to pass in a W, and what I want to set is the weight. So let's change this to weight, and weight will be equal to W. So sorry about that. So I forgot that I had already set number of wheels. So in our second constructor, instead of number of wheels as a parameter, we're setting weight. So we're passing a W that will hold the value for weight, and setting weight equal to W. And then we're passing in another parameter for type called which we're storing in T, and then we're setting type equal to T. So here I would like to print the weight, and then I would like to print the type. Okay. So in order to use this parameterized constructor, let's go back into our main program. So let us create a second vehicle. Okay, so vehicle, and we're going to say vehicle 2. Now when you're defining or creating the instance or object, and you have a constructor that takes parameters, you can set those values as soon as you create your object. So once you type in the name of your object, then you can open up your curly braces, and this will allow you to set the values in the order that you have defined them here in your constructor. So the first value or parameter would be an integer, and the second parameter would be a string. So let's say the weight of the vehicle is 1,000 pounds or kilograms, and the second parameter, and let's say our vehicle is a sedan, and then we put our semicolon. All right, so now if we want to print the vehicle info for vehicle 2, and let me just actually change this to vehicle 2. So now we're going to print the vehicle info for vehicle 2. So let me run this. Okay, and now we're getting an error. And I know exactly why we're getting this error. So let's go back to our program. So back here in our header file, The reason is that since we are in fact setting parameters here for weight and type, we need to pass in a parameter. Actually, this should be a double. Now we didn't get an error for that because the value we actually passed in was it didn't have any decimal numbers in it, so that's why we got away with that. So yes, since we are passing in values, we actually now have to pass in or have a parameter for wheels, and here let us simply say number wheels is equal to wheels. Alright, so what I did was I simply added a parameter to set the number of wheels. So I'm passing in a value and storing it in wheels. And then I'm setting the attribute of my class, which is number of wheels, to the value that is passed in. So let us go back here. And now we have an error. So let us fix that. So the first parameter will be 4. All right, and that's for vehicle 2. So now let us pass in, let us run our program. And here we get all of our values. So if I was to set any value here, let's say we had a vehicle with 8 wheels, or 18, let's say 18. And let's call this a trailer. Alright, so 18 wheeler. Let's run this. And of course we get the values that we pass into our constructor. So back here in our header file, I'd like you to define a function called set vehicle info, and what your function will do is actually set the values for our vehicle, just like we did here with the constructor. But instead of using the constructor to do it, I'd like to define another function that would set the values for each one of these attributes. So far we have wheels and weight and type, and we want to define a third vehicle. So can you think of how you would define that function? Just take a minute and think about how you would set values using a set vehicle info function. So pause this video and try it out on your own, and then we're going to take a look at the solution next. All right, so hopefully you have tried to set up your setter for this class. As you can see here, I've defined a setter, and I've also made some modifications to my getter. So let me walk you through the changes that I have made. So here with my setter function, I've defined a set vehicle info function that returns a void. I have added 4 parameters that will set the values for each one of my attributes. So I'm passing in, similar to our parameterized constructor, I'm passing in 4 parameters: wheels, W for weight, T for our type, and HYB for short, that will store our hybrid value. And then inside the function, I am setting each one of my attributes, number of wheels, weight, type, and our boolean equal to the values that are passed in as an argument to my set vehicle info function. So that is essentially what is happening here. With my getter, what I have done, I've simply added a string to each one of my print statements. So I'm just printing out a formal sentence. So right here I am just saying the vehicle has, and then it will print the number of wheels and then the string wheels, and then it's saying the weight is whatever the weight is and in kilograms, and this is saying it is whatever type of vehicle we define. And in our last line, this is what is known as a ternary operator. So with a ternary operator, it simply means it's just a different definition of an if-else statement. So with a ternary, here you see we have a condition inside of our parentheses. So we're checking to see if our Boolean hybrid is equal to true. So this section before the question sign, this section that begins our ternary would be our if statement. So imagine this as if hybrid is equal to true, then what comes after our question sign would be our first, if that condition is met, this is the first action that you'd want to take. So if it is an hybrid, then I want to print, oh, it is a hybrid. And then here you'll see this is that's a semicolon here. So that's what a ternary is made up of. We have our condition in a parenthesis, followed by the question sign and the first condition, or the first action if the condition is met. And if that condition is not met, then we put a semicolon and we want to do our second action here. So if the condition is met, it's a hybrid essentially, and if it's not, then we're just going to print it's not a hybrid. So a ternary really works as an if-else statement, but it only works really for two values. So if it is true, it will do one thing. If it is not true, it will do another thing. So if you want to do multiple checks, it is probably recommended that you stick with the if-else or implement a switch statement. All right, so let us test out our set vehicle info function and our new print vehicle info function. So let's go back to our main. And what I'll do is define a third vehicle. So let us call this vehicle 3. And now I'm going to say vehicle, let's say vehicle 3 dot set vehicle, not print. Let's undo that. Dot set. So you see here we're getting some help. So the first parameter is wheels, which is an integer. So the number of wheels is 4, comma, then we have our double. So we need to set our weight. So let's say it's 1200. Then we need to say the type. So our type is let's call this a race car. And it's a hybrid, and of course if it's a race car, then it most likely is not a hybrid. And let's put our semicolon. Now let us print our values for our vehicle 3 object. So let's now run our program. All right, so we see here we have the values that we have entered. All right, now vehicle has 4 wheels, the weight is 1200 kilograms. It is a race car and it is not a hybrid. So as simple as that to set your setter and getter functions. And let's test our ternary operator to see if it's working properly. So if we were to set this value to true, then it should actually print that the car is a hybrid, right? So we see here now that it is set to true. it is printing, it is a hybrid. All right, so there you have it. We have set up a class, looked at how to define behaviors and attributes. But the last thing I want to do is do a bit of cleanup in this class, just to define things a little bit better. So if you recall, we got some garbage values before when we created our vehicle 2, and we did our print vehicle info, called our print vehicle info function. It printed a garbage value for a number of wheels, right? So if we were not defining a default constructor, the compiler would automatically define what is known as an implicit default constructor. So if we did not have this, our parameterized constructor, the compiler would create one for us, right? So if we did not have our default constructor initializing any of our variables, then that would cause some problems, as you saw with the garbage values. So the members would be uninitialized. So in general, it is a good practice to initialize your member variables or your attributes, even when you're not relying on an implicit constructor. So even though we have a default and a parameterized constructor, it is good practice to initialize these. So we could do that several ways, as we've seen before. So we can either use the equal assignment operator, or we can simply use our curly braces to define a value. So I'm just going to define a 0 value. All right, so we're just going to initialize with a 0. So with our double, we can say 0.0. With our string, let's just set this to an empty string. And with our hybrid, let us just set this to false by default. All right, so next, let's go to our default constructor. So now that we actually have a setter that sets the values for each one of our attributes, we no longer need to do this action of setting a default value here. And usually in our default constructor, what it does, it just allows us to perform some action, right? So whatever action we would like. And actually, let's just leave this empty. Let me put it as a print statement. So let's say cout so it performs some action. And that's really, let's put a new line here. That's really what it's there for. So anytime an object is created, it's just going to perform some default action. All right. So next, our parameterized constructor. So there is actually a better way, instead of passing in our values like this and then setting the values inside our function body like this. There's actually a better way that is recommended. And this recommended method is known as using a member initializer list. So a member initializer list is preferred over assigning values in the function body or in the body of the constructor. It's preferred because it directly initializes the member. So this works, as we've seen, but it is not the recommended way to do it, or the preferred way, I should say, to do this. So let me comment out this default constructor, and let me copy just this first section here. All right, so we have exactly the same thing that we had up to our closing parentheses. And the way to define a member initializer list is to use a colon after our parentheses. And then what we would do is say number of wheels and then open up parentheses, and inside of this we would put the value or parameter value, which in this case is wheels, and we would separate it by a comma, and then we would say, we would do it for each one, so weight, and then this would be W, type T, and okay, so we did not have a boolean here, and then we would just have a open and closed function body, so nothing would actually be inside our function body. So this is the preferred method. Right, so this would work exactly the same way as it did before, and we can test that theory. So let us come here. All right, so we have let us set this to vehicle 2. Let's comment this out for now. So if we were to print vehicle 2 info, right, so we see here that the default constructor gets called, it performs some action, and then the vehicle has 18 wheels, it weighs 1,000 kilograms, it's a trailer, and it is not a hybrid. All right, so we see that it works exactly the same way as it did before. All right, so the next thing, and actually the last thing we will do in this example, is let us create a third object called vehicle 3, and what we're going to do here is say vehicle 3, and we're going to call our set vehicle info function, and when we open up our parentheses we see the different parameters that the function takes, and now we are going to pass in our arguments. So the first argument will be an integer, so the number of wheels, which it will be 4, and then the weight of the vehicle. Let's say this vehicle weighs 2,200 kilo. String type, so that has to be in quotations. So let's just call this, a hatchback. And thirdly, our boolean type, so let us say true, because it is already automatically set to false. So let's end that with our semicolon, and let's change this to vehicle 3, and let us check out what we get. So if we run our program, okay, so we see here that perform some action is being called twice, and the reason for that is we have several instances of our object. So let me comment out these for now. So we're only going to deal with vehicle 3. So we're setting the info and printing the info. So let me double check one thing. Okay, so this is throwing a new line. So let us run this again. All right, so we see the default constructor gets called, and it performs some action. We see the vehicle has 4 wheels. The weight is 2,200 kilo. It is a hatchback, and it is a hybrid. So if we change this to false and run it, we see that the vehicle is not a hybrid, so our ternary operator is working just fine. We've been able to abstract away a lot of the logic in our program at this point. So we see we have created a class, and now in our main, the only thing we have to include is our header file. Similar to how we only had to include IOStream to be able to use certain functions from that library. So we've created our own custom library, and instead of having all the functions and logic in our main file, we've simply included a header file, and we're able to work with those objects and those libraries right here. So let me demonstrate how we can abstract away some of this logic even a bit further. So I'm sure at this point you are wondering, what is this vehicle.cpp file for? So I've already made a comment. We're going to be adding the member functions of our vehicle class as it is, linked to our vehicle.header file. And to do this, we will have to create our member functions in this file. So we will be removing the logic from our class file. So in order to do this, we will be pretty much like we did before, where we did the function prototype above int main, and then we had the function definition below int main. It's similar to it's pretty much similar to the concept we're about to explore now. So we're going to copy this function, and we are going to delete the function body and leave the function prototype. So we're going to put a semicolon after the function signature. So now there's us, it's not really an error, but it's letting us know that the function definition for set vehicle info is not found. So let us go over to our vehicle.cpp class, and in order to link our function to our header file, we first have to do a couple of things. So the first thing we need to do is we have to, and let me make a list up here. So first we have to define the function type. Then after the function type, we have to define which class the function belongs to. So in this case, the function belongs to the vehicle class. And then we have to use our scope resolution operator. And then we do our function definition. All right, so let me demonstrate this for you. So first we do the type. So we know that the type of function, the return type, is a void. So let me actually specify that we need a return type. So it's a void, and then the function, and then the class name is vehicle. And then we need our scope resolution operator. So this helps us to resolve our function to our class. And as soon as we enter that double colon, we see it is already finding all the different data members in our class. So what we need is I believe we're doing let's double check, set vehicle info, right? So we need to say set vehicle info. And then let us paste. Okay, so let's undo this. And let's paste this and remove the void. Okay. So let's walk through this again. So first we have the function return type, which is void. We have the name of our class. We have our scope resolution operator. Then we have our function definition, which of course includes the function name, the parameters for our function if we have any, and then the function body. So we have defined our set vehicle info function, and now we'll do the same thing here for our print vehicle info. So I'm going to copy the whole function and then delete the function body, and then now we're deleting. Okay, yes, there we go. And then terminate with a semicolon. Let's come back over here, and I'm just going to paste the function, and then let's follow the same method. So we have the return type, which is void. Then we have the vehicle, which is our class name. Then we have our scope resolution operator. And since we already have the function definition, we can just delete that space, or we could leave it. It doesn't matter. So here we have defined both our member functions for our vehicle class. So we see now that we have abstracted the logic for our functions here. We've abstracted it away to even yet another file. So the reason for this, you could now probably, so think of this as a way to hide your, logic, or maybe company secrets. Maybe you work for a stockbroker and you have an algorithm that calculates how to trade the market and make a good profit each day. And maybe you don't want everybody to be able to see, the algorithm that is able to perform this task. So you could probably just provide them with the function, let them know that, hey, we have a function that trades stocks and it accepts, your starting bid. It accepts, the closing bid, and however it works, right? So those will be the parameters that the function accepts, and then that's all the user would probably need to know, or whoever is working on the program, maybe that's all you would want them to know. You wouldn't necessarily want them to know how the algorithm works, or to be able to see that maybe you don't want them to steal it and, give it to a competitor, something like that. So that's pretty much abstraction, and we've now been able to move our logic over to another file, and now you see that our class is even a little bit, cleaner than it was before.